Good morning, everyone, especially to our teacher, si Reynaldo Corpus. Today, we will report our topic entitled Modern Encryption Techniques, Symmetric Block Cipher. Modern Encryption Techniques, Block Cipher. In fact, all symmetric block encryption in current use are based on a structure referred to as a festal block zipper. For that reason, it is important to know the design principles of festal zipper. Ano nga ba ang block zipper? Ang block zipper ay isang paraan ng pag-encrypt na naglalapat ng deterministikong algorithm kasama ng isang simetriko na key upang i-encrypt ang isang block ng text. Sa halip na i-encrypt ng paisa-isa tulad ng mga stream zipper, halimbawa, ang isang karaniwang block zipper AES ay nag-e-encrypt ng 128-bit na mga block na may susi ng paunang natukoy na haba 128, 192 o 256 bits. Ang mga block zipper ay ang pseudorandom permutation o PRP na pamilya na nagpapatakbo sa nakapirmang laki ng block ng mga bit. Ang mga PRP ay mga function na hindi maiiba mula sa ganap na random na mga permutasyon at sa gayon ay tinuturing na maaasahan hanggang sa mapatunayan ang hindi mapagkakatiwalaan. Ilan sa iba't ibang mga mode ng pagpapatakbo para sa mga block zipper ay kinabibilangan ng CBC or Cipher Block Chaining, CFB Cipher Feedback, CTR or Counter, at GCM Gallios Counter Mode.
A stream cipher is a symmetric key cipher where plaintext digits are combined with a pseudorandom cipher digit stream. In a stream cipher, each plaintext digit is encrypted one at a time with the corresponding digit of the key stream to give a digit of the ciphertext stream. A stream cipher is an encryption technique that works byte to byte to transform plaintext into code that's unreadable to anyone without the proper key. Stream ciphers are linear, so the same key both encrypts and decrypts messages. Stream ciphers are classified into two types. First is the synchronous stream ciphers, and the second, the self-synchronizing stream ciphers. However, self-synchronizing stream ciphers fell obsolete, mainly because of the existence of a resynchronization mechanism in most modern synchronous stream ciphers. Stream and block ciphers. An important distinction in symmetric cryptographic algorithms is between stream and block ciphers. Stream ciphers convert one symbol of plaintext directly into a symbol of ciphertext. Block ciphers encrypt a group of plaintext symbols as one block. A block cipher breaks down plaintext messages into fixed-size blocks before converting them into ciphertext using a key, encrypting information bit by bit. A stream cipher, on the other hand, breaks a plaintext message down into single bit, which then are converted individually into ciphertext using key bits. Stream are faster and more efficient than block ciphers because they are encrypting only one bit of data at a time into individual symbols rather than entire blocks, so they are better suited for devices that have fewer resources.
Stream cipher and block cipher. A stream cipher is one that encrypts a digital data stream 1 bit or 1 byte at a time. A stream cipher is an encryption technique that works by byte to transform plain text into code that unreadable to anyone without the proper byte stream ciphers are linear so that same key both encrypt and decrypts messages. And while cracking them can be difficult, hackers have managed to do it. A block cipher is one in which a block of plain text is treated as a whole and used to produce a cipher block of equal length. A block cipher is an encryption method that applies a deterministic algorithm along with a symmetric key to inner a block of the text rather than encrypting 1 bit at a time as in stream ciphers. The major difference of stream ciphers and block ciphers is that the block ciphers encrypts and decrypts a block of the text at a time. On the other hand, stream cipher encrypts and decrypts the text by taking the 1 byte of the text at the time.
While block cheaper versus stream cheaper, process message block 64 bits or more versus a bit or a byte, many current cheapers are block cheapers. Block cheapers look like an extremely large substitution. Ideal block cheaper would need a key of n asterisk 2n size for a n-bit block cheaper based on Fistel cheaper structure.
Fistel cipher structure. From the year 1960 to 1971, a group from IBM led by Horst Fistel had initiated a research project named it as Lucifer for computer cryptography and became the first ever known block cipher operating 64 bits per block using 128-bit key size. This algorithm was also known as Festal cipher. Another effort was again initiated by IBM in 1973 to produce a commercial encryption scheme and name it as DES or Data Encryption Standard. This was led by Walter Tuchman. The DES is actually an improved version of the project Lucifer, which was noted as resistant to encryptanalysis. The DES was adopted as federal standard and was used by U.S. government communication in 1976. With a very strong internal structure of DES, it was used over 20 years.
Confusion. Confusion means that each binary digit or bit of the ciphertext should depend on several parts of the key, obscuring the connection between the two. The proper of confusion hides the relationship between the ciphertext and the key. This proper makes it difficult to find the key from the ciphertext and if a single bit in a key is changed. The calculation of most or all of the bits in the ciphertext will be affected. Confusion increases the ambiguity of ciphertext and it is used by both block and stream cipher.
Diffusion means that if we change a single bit of plain text, then about half of the bits in the ciphertext should change. And similarly, if we change one bit of the ciphertext, then about half of the plain text bits should change. This is equivalent to the expectation that encryption schemes exhibit imbalance effect. The purpose of diffusion is to hide the statistical relationship between the ciphertext and the plaintext. For example, diffusion ensures that any patterns in the plaintext, such as redundant bits, are not apparent in the ciphertext. Block cipher achieved this by diffusing in the information about the plaintext structure across the rows and columns of the cipher. Diffusion means that if we change a character of the plaintext, then several characters of the cipher should change. And similarly, if we change a character of the ciphertext, then several characters of the plaintext should change. We saw that the Hill cipher has this property. Diffusion means what if we change a single bit of the plaintext, then about half of the bits in the ciphertext should change. And similarly, if we change one bit of the ciphertext, then about half of the plaintext bit should change. What is the purpose of diffusion in design of a block cipher? Diffusion is a cryptographic technique invented to increase the redundancy of the plaintext, obscure the statistical structure of the plaintext to prevent attempts to deduce the key. Confusion and diffusion. Cipher needs to completely obscure statistical properties of the original message. Diffusion makes the relationship between plaintext and ciphertext as a complex possible. It is obtained by substitution and the following function. Confusion make the relationship between ciphertext and the key complex as possible. Confusion and diffusion are two properties of the operation of secure cipher. Confusion refers is making the relationship between the ciphertext and the encryption key as complex and involved as possible. Diffusion refers to dissipating the statistical structure of plaintext over the bulk of ciphertext. In cryptography, confusion and diffusion are two properties of the operation of a secure cipher identified by Claude Shannon in his 1945 classified report, A Mathematical Theory of Cryptography. These properties, when the present work, that thwart the application of statistics and the methods of cryptanalysis. What is diffusion and confusion used for? Confusion is a cryptographic technique which is used to create faint cipher text, while diffusion is used to create ciptic plain text.